Pittsburgh, Smoky City, Steel City, Robot City. For over a century, Pittsburgh thrived on steel. The steel mills churned out smog so thick that it blotted out the sun. Street lights remained on even during the day. This was seen as a sign of prosperity. Eventually, outdated manufacturing and depleting natural resources led to its destruction, forming in its aftermath a new industry, robotics. Pittsburgh has become a place of monumental ambitions. Its mechanical arms are reaching for the stars. But some are starting with the moon.
My life is robots, robots, and robots. I've had the privilege and adventures of robotic cleanup of nuclear accidents, the creation and mastery of robot car driving, land, sea, air, underground, and now to space. I conceived for the concept of drilling for the ice at the moon and had those ideas rejected for years on the basis that there was no evidence for the existence of ice. And now, of course, it's a sure bet, and the agenda is to robotically reach the surface and to drill that ice. Robotics in space have not been linked forever, except in science fiction and great movies. It was a one-time venture by the Soviet Union to put the lunokhod on the moon, but except for that, there are no other robots on the moon. Human capabilities in space are intrinsically constrained by the life support and the mass that's required and the issues of long radiation exposure. So the missions that are on the books are all robotic. That's a transformation of my lifetime. I got the idea for robots at work at a time when robots were just fantasy and science fiction. And I had a vision for robots to develop, secure, feed this world, and to explore worlds beyond. I embraced that. There was no looking back.
My interest in robotics, in robots, began when I was a small child. I was always interested in motion, whether it's the way cars drive, animals' motion. And as a child, I was lucky enough to find some small computer and hook it up to motors from Radio Shack. And I was able to make these toy cars move around the way I commanded, because that's the ultimate, being able to command that motion. Right now we're in my lab. It's called the BioRobotics Lab. It has its name because a lot of the work we do is inspired by biology. So my group has done a fair bit of work in snake robots. They bear their name because, you look at them and they look like snakes. It has many, many extra joints, many, many extra degrees of freedom. These degrees of freedom allow the robot to thread through tightly packed volumes and get to locations that people and machinery otherwise can't access. So one application is urban search and rescue. Here you have a collapsed building. Rescue workers want to locate trapped survivors, but it's a very dangerous situation. The structure is very fragile. It's dangerous to the rescue worker. Also, it can be dangerous to the victims because you don't want to cause collateral damage. These robots have the potential to serve as a tool to extend the sensory reach of rescue workers so they can locate victims more quickly. Urban search and rescue, inspection of nuclear power plants, archaeology. In all these cases, we're doing minimally invasive surgery on a structure. So it stands to reason, if we shrink the robot down to a small size, we can do minimally invasive surgery on a person. We're trying to deliver a tool to physicians to perform capabilities that otherwise were relegated to surgeons.
Just over 200 years ago, the first steamboat was built on these rivers. It squandered natural resources, polluted the rivers, and required a crew of over 20 men. This boat requires zero.
Platypus builds these small, low-cost robotic boats for applications such as environmental monitoring, fish farms, pollution monitoring.
We were able to build these really low-cost boats by leveraging existing Android phone technology along with custom electronics and package that into a really low-cost foam and plastic hull that we could fabricate. It's smaller than a lot of people expect. We get this all the time where people come in, they look at our boats and like, wow, that's way smaller than I expected, you know. I was expecting a boat. So for one example, we can go into small streams and small rivulets and things like that without too much problem because we have such a narrow and short base. The other thing is that these sensors are just tiny, tiny 1-ounce things that are strapped onto basically these really huge boats and then dragged around right now. And there's no reason for that. And so by actually going to these smaller sizes, you can hit kind of a sweet spot where you can use much cheaper hardware to actually push them around.
We've just got to keep going down that path of making a cheaper, more robust, more repeatable, more usable robot, and then the killer apps are there. I hope.
How can I help you? May I assist you? Need anything? Your wish is my command.
We're currently at the experimental stage. We're in the petri dish, trying to figure out what the best robot is, what should it look like, what infrastructure should it have, should it be running ROS, should it be running Linux? No one really knows what the robot of the future is going to look like. It may look like a Roomba, it may look like a 5-armed robot, who knows, right? We're here at the Personal Robotics Lab. It's a lab that I started, and this is our robot Herb. Herb stands for Home Exploring Robot Butler. Everything is completely self-contained. He has lasers to map the environment, he has cameras to recognize and register objects, he's got his arms to pick up objects. And it took us about a year to take that first step to get Herb to actually recognize and register an object, it was actually a coffee mug, and pick it up. And doing all of this completely autonomously, right? We didn't tell him where the coffee mug was. We didn't tell him how to pick up the coffee mug. He had models of physics underneath that he was using to evaluate how to grasp objects. There was a tremendous amount of autonomy and tremendous amount of artificial intelligence, motion planning, perception that goes into executing even a very, very simple task. It's very rare that we can actually make true impact in the world and actually help people. My grandmother is in India and she's very old, and we constantly worry about her. And if we can build technology that can help her perform the kinds of tasks that she's used to performing in the home, that would be extremely rewarding.
So what we're doing right now is monitoring my level of attention. I have it set up so a threshold value of 80 will cause the hand to grip. Right now I'm shooting about 14, so let me concentrate. Get that guy going. Here it comes, there we go. And that will stay gripped as long as my concentration value is higher than 80. The thumb movement is done by a blink function. And the coordination of the two will allow for a large degree of dexterity. I mean, CMU is great, don't get me wrong. It affords a very knowledgeable base of people to talk to and to collaborate with. Certainly their facilities are very, very top-notch.
We've noticed that universities rarely bring things to market. They kind of get caught up in the system. We worked there for 6 months and became pretty frustrated. It's really cool technology. It's really helpful, but it doesn't help anyone if it actually doesn't come out.
What we're working on is an assistive technology, specifically right now a prosthetic arm. And the technologies that we use are EEG and EMG technology, which means that we create an artificial nervous system, essentially. When you concentrate on and bring your attention level up, it'll close the hand. Prosthetics really are not, they're either not functional or not affordable.
We want to find a balance between functionality and cost. So keeping something that's affordable to people, but delivers far more functionality than your average sort of hook.
I mean, the technology that we're developing is a broad range of applications, from just giving somebody their life back by allowing them functionality of a limb to surrogate robotics. We look at what people have access to now and kids have access to now, we're just blown away.
Well, it's amazing at the Maker Faire, these kids would come up to us and be like, that's an Adreno Mega, and
they'd be 7.
Yeah.
And they would ask us really kind of technical questions. Technical questions that we don't hear from adults. I mean, you have in Pittsburgh lots of really good schools, right? So you have people from all over the country, all over the world, coming to this region to develop their ideas and learn new things. But that doesn't end when classes end. These people go out, they interact with the community. And it fosters a development process unlike any educational system could. You also don't need to go to CMU to learn robotics. I mean, I did it for a couple $100 and library fees. We do this stuff all the time. There are solutions out there. All you have to do is know what questions to ask.
Pittsburgh, Smoky City, Steel City, Robot City.